All right, we will go ahead and get started. Thank you everyone for joining us for our first customer-facing webinar here at Logz.io. My name is Zoe and I lead customer marketing here. This is going to be a monthly program, so we appreciate you joining us to kind of be our guinea pigs. Each month we'll be digging into either new features or spotlighting existing ones that you may be underutilizing in your Logz.io solution. So thanks for joining us today to learn about distributed tracing and service performance monitoring. Today, our presenters are Dotan Horowitz, our principal developer advocate, and Aria Fischler, the product manager who is in charge of distributed tracing. And before I turn things over to them, I have a few pieces of housekeeping. First, if you have any questions during the webinar for our presenters, please enter them into the questions section of your control panel. Dotan and I will be monitoring these and we'll answer them either as they come up or at the end of the session, whichever makes the most sense. And if for some reason we can't get to your question, I'll make sure that you get your answer directly from your account team. Secondly, we are recording this session and there will be an access link provided in a follow-up email later this week. So keep an eye out for that. And finally, there is a survey that will pop up at the end of the broadcast. This survey will help us plan future customer webinars and other enablement content to make sure that you have everything that you need to maximize your success with Logz.io. There is an open-ended question at the end where you can provide any feedback, comments, ideas related to the webinar or not. A real person will review all of those responses, and that real person is me. So don't hesitate to reach out with anything that you can think of that you might need. And with that, I will go ahead and hand it over to Dotan to get us started. Ready to go?
Thank you very much, Zoe, and glad to be here, and thank you everyone for attending. And today we're at the webinar about destroying data bottlenecks with distributed tracing. We'll have essentially two parts for this session. The first part, I will talk about primer on distributed tracing and the Jaeger open source, understanding what is that, why we need that, the distributed tracing discipline and the open sources involved. And then on the second part, Aria, my colleague and the product manager leading the distributed tracing product, will talk about the product itself. We'll show a demo. We'll talk about service performance monitoring in particular and Logz.io's offering. So let's dive straight into the primer on distributed tracing and the Jaeger tracing open source project. And let's start with why we need distributed tracing at all. And indeed, it's a new discipline, and until, I don't know, a decade ago or so, in the monolith application era, as it's currently called, we didn't really use distributed tracing, most of us. We used metrics to help us identify that something happened. And then it was pretty easy to root cause the issue by looking in the logs, looking at stack traces, even maybe stepping through the code with breakpoints. But then again, in the current microservice era, the microservice architecture, when we have hundreds of services that participate in satisfying a single request, if now a request fails or if I see performance degradation on an endpoint, how could I identify the root cause for that? So going back to what we used to do, like I don't know, putting breakpoints, stepping through the code in debugger, obviously that's not really feasible to run the entire microservice stack locally. And then reading the log output, then now let's remember we have hundreds or thousands of services and each service handling hundreds or thousands of different requests per second. So finding these log entries for a request that we want to investigate, the problematic one, scattered across so many log files is very hard. Not to mention to try and determine the causality, to jump from one to the other, to trace the whole context. And as our application grows, it's becoming practically impossible to track the execution flow. And what you can see here on the screen is an actual screenshot of a subset of Uber's microservice architecture. And just try and imagine trying to trace a single transaction through this net. So this is exactly what distributed tracing comes to solve. Distributed tracing is a method for profiling and monitoring applications, and I guess the most important thing to take out of this definition is the last part, that it helps us pinpoint where failures occur and what causes poor performance. So again, if suddenly I have a failure on an endpoint, 404 or something like that, then I would like to know where this failure, the root cause of this failure within the, I don't know, maybe hundreds of participating microservices and so on. Or if I get a slowness on the, I don't know, login endpoint, how do I know where this slowness stems from? Where exactly in the flow is the application's most wasteful hop? These are the main use cases for distributed tracing. And indeed, we see that distributed tracing is picking up rapidly. This data that you can see in front of you is taken from the DevOps Pulse survey. This is a yearly survey we run at Logz.io about the state of DevOps and observability. And for the past 3 years, we've been seeing steady increase in the adoption of distributed tracing. Currently, as you can see, it's the third after logs, logging and monitoring on metrics, essentially. So definitely, and amongst those who don't yet use distributed tracing, 70% indicated in the survey that they're planning to start using it in the coming 1 or 2 years. So tracing definitely stands out as a central tool for monitoring microservices and distributed systems in general, augmenting logs and metrics, of course. So now that we understand why we need it and what it is, I would like to give some basic terms and concepts from the distributed tracing realm. And the most foundational term is the trace, which is the record of activity of a request through our microservice architecture. And you can imagine that, visualize that as a distributed acyclic graph of spans, like you can see here on the left-hand side, where each circle here is what's known as a span, which represents a single operation within the trace. So it contains the service name and the operation name that was invoked, the start time, the duration, and many other logs and metadata and tags on top of it. And you can think about a span as a structured log, essentially, reporting that specific operation that was invoked. And it could represent anything. It could be a simple activity, or it could be a very complex logic. It's really diverse. Where the beginning of that trace is the root span, the one that the endpoint, that invoked the request. Usually, the trace is being visualized as a timeline view or a Gantt chart, like you can see on the right-hand side here on the slide, which shows very neatly the flow. So you can see here A, which is the root span, obviously taking the full length, the full duration of the request. But then again, as soon as A starts, it calls B, and then we can see shortly after B starts executing, it calls C. As C finishes, then it calls D, and when B finishes entirely, then A calls E. So you can really see the flow of execution. You can see which spans ran in parallel and which ran sequentially. You can see how long they took relatively and where most of the time is spent. It's very good visualization, very good UI that usually is used for investigating traces. Another important concept and term in distributed tracing is the context. The context is the data required for moving the trace information across service boundaries. So it contains the trace ID, a global identifier for the trace, and then a set of other unique identifiers, and potentially the application essentially can capture also diverse additional context, such as the URL for an HTTP request or an SQL statement for of a database query. It's really up to you and up to your instrumentation, and it can be very powerful. And context is essential for distributed tracing, actually much more so than other types of telemetry, because the whole power of distributed tracing lies in the context. And the context propagates through the system. This is how the context is bundled and transferred between threads, components, processes, service boundaries. Typically, it's done via HTTP headers, and there is a W3C specification for that. But typically, you will not need to be bothered with that, because it will be taken care of for you by the underlying instrumentation. So that was very briefly some basic terms about distributed tracing. And let's see how it looks like from the system view. As we said, each microservice, independent of which programming language it's written in, emits these spans, these sort of structured logs. And then there's a collector that collects all these spans and reconstructs the trace based on causality, and then it sends it over. And you can see here an example here of the span: service front end, operation HTTP get/dispatch, starts at this time, duration this time. So really conceptually you can think about it as a structured log. And then the collector sends the full trace to the backend for storage and analytics. It's important to understand that what happens in the application that allows it to emit these spans is what's known as instrumentation. It's a process of actually allowing the code to emit. It could be manual instrumentation, the same way that we do with logs, just adding a line that says, let's output this string with these parameters and these, I don't know, error level or something like log level. This is a manual instrumentation. You need to add something to your code to emit the span. And for some frameworks and programming languages, there's also support for automatic instrumentation, auto instrumentation, where you just install an agent that adds these traces to your application without needing to make any code modifications. The last term that I would like to mention is sampling, which is important because for efficiency reasons, we typically don't sample 100% of the requests, but rather only a sample. And the decision which traces are sampled is based on something that is called a sampling policy. It could be a probabilistic policy, like please collect 0.1% of all the traces. It could be a rate limiting based or others. And the sampling, and it could be different strategies as well, head-based, tail-based, and so on. I'm not going to go into all of that. I'm sure that Arya will elaborate on some of that further. The main takeaway that I would like to emphasize for you is that the policy enables you the flexibility to keep it efficient while still provide good observability for your system. The popular open source stack out there uses OpenTelemetry for both the application instrumentation and the collectors. So it provides SDKs and auto instrumentation agents for generating these spans in your application, and then an OpenTelemetry collector for collecting, and then Jaeger for the analysis backend. And indeed, Jaeger is clearly the most popular tool for distributed tracing amongst distributed tracing users, again, from DevOps Pulse survey, as you can see. So this is why we identified it as the best of breed open source tool, and generally a tool, as you can see, also compared to non-open source tools. And this will be the focus for this webinar. And I would like to just give a bit of a background about Jaeger tracing. It was built by Uber back in 2015, inspired by Google Dapper, which is a very prominent paper that Google published back in 2010 about distributed tracing, a monumental paper that influenced all the industry, that was written on the tool that they developed in-house for their own tracing. So that research paper, and also by Zipkin, another open source or more veteran open source. It was then open sourced and contributed to the CNCF, the Cloud Native Computing Foundation, back in 2017, and then reached graduation from the CNCF in 2019. So it's already been around for a good few years, in production, used by many organizations. If you are interested in hearing more about how Uber developed Jaeger and used it in their scale, I highly recommend the Open Observability Talks podcast episode that I had held with an ex-Uber employee that worked on the Jaeger team. Fascinating story about how they did that, and lots of best practices about using Jaeger. And now I would like to say a word about instrumentation with OpenTelemetry. Some history we saw before the pipeline, the system view. Jaeger was originally providing the whole stack, the client libraries, the agents, the backend, everything, and the client libraries were based on open tracing, open specification, but then open tracing merged with open census, another project, to form OpenTelemetry, and OpenTelemetry gladly reached general availability, GA, for tracing last year in 2021. And since then, Jaeger moved to using OpenTelemetry for both the client libraries, the SDKs, for instrumenting the application, and for the agent. So as I showed before, the stack currently uses OpenTelemetry for both the instrumentation side and the collection side. OpenTelemetry in general is a framework for generating and capturing telemetry data, not just for traces, but also for metrics and logs. So in a way, it's one open source framework to rule them all the observability pillars. And indeed, at Logz.io, we utilize OpenTelemetry for collecting logs, metrics, and traces in a uniform manner. So, and also, if I mention Logz.io, we are contributors to the OpenTelemetry project. We donated the span metrics processor for the OpenTelemetry collector that Arya will mention. We also provide a distro for OpenTelemetry collector. So we're very much involved in the OpenTelemetry open source project upstream. Very similarly, we also are involved in the Jaeger open source project. We developed and donated the service performance monitoring capability and theme into the open source, as Arya will show later, and many other things on the UI side, on the backend side, and many more. And we're also obviously involved in many other open source projects such as OpenSearch and others. So it's part of our mentality, being open source first and providing the best of breed open source to our users, and also supporting the relevant communities and contributing back to the communities and to the projects. So that's about what is distributed tracing and about the relevant open source tools. And now it's time to hear about a managed version of these open sources. And for that, let's enter Logz.io, and I'd like to move it over to Arya to show you the Logz.io offering.
Hi, Dotan. Thanks for the great introduction. Let me switch to my share of the presentation. So hi, everybody, from me too. I'm Arya, part of Logz.io product group, and mainly focus on our distributed tracing and service performance monitoring. I'd like to take you through the Logz.io implementation of distributed tracing and Jaeger, and see how it blends into the overall offering of Logz.io that is much more than a bare open source product. So as you heard about Jaeger is a great open source project that gets a lot of traction, a lot of usage. Naturally, you can take Jaeger, download it, and use it on your own infrastructure. But handling your own open source combined with other solutions is never that easy. And for that, we took Jaeger and blended it into the overall Logz.io platform that includes, as a vision, a collection of open source solutions. As you might know, as users of Logz.io, we started with the log solution currently based on OpenSearch. We also have a metric backend based on Prometheus and Grafana. And now Jaeger was added as the third product, and they all together combine an open source observability solution. And what does it mean? In general, you see that the products are only on the bottom layer of the solutions of their overall platform. On top of it, there are several layers that make your usage and easiness of usage much more powerful. So our layers that are added on top of that provide security, different standards that are important for many industries in the enterprise level, a lot of data optimization that is done around your data, trying to minimize the amount of data you send to us or make use of. Organize the data into different sub-accounts, which means you can handle many environments under one account without needing to maintain different platforms, different deployments. So in a high-level view, you can see that the overall Logz.io platform consists of many technologies that come together to offer one platform that is providing support for all the telemetry you need for proper observability of modern software systems. And on the left, you can see that we support, this is just a small sample, tons of integrations and abilities for you to send the data. You just need to implement it once and data flows in. And from that point, we can visualize your data in different ways. We'll move now to a demonstration of the product and platform that will emphasize what you can do with it, not just the mere features that we will also see. Naturally, when you go ahead to troubleshoot an incident, you normally want to be alerted, you want your observability system to be proactive in detecting some kind of situation, some kind of event. So this is the first step, but once you have it, you need to take a look to see how critical it is, how severe, how problematic. Is it a real problem or just something that happened for a second and will fix itself maybe in the next moment? Once you establish confidence that this is like an event that needs attention, you will want to determine the root cause and then go to different components of your observability to be able to fully troubleshoot and go down to the reason of the event. So with that, let me explain a little bit on the environment of our demo. You can, we jump here just right into Jaeger to a feature called System Architectures. System architecture shows a diagram of how your service communicates. And I will use this to explain what are we going to see here. We're going to see a demonstration of some kind of e-commerce platform called the Sock Shop. Naturally, you can buy socks on the Sock Shop, and you can see the microservices represent a very typical e-commerce scenario. You have your front end where the requests come in to the back end. You have a component that is in charge of orders and naturally shipping, and of course the payment, which is really important, critical for the business. It sets our revenue and we measure everything around this revenue. It's a normal business. We want to grow our revenue. And looking at that, we can understand immediately how data flows when you have like hundreds or maybe thousands of microservices, then it will be harder to know everything by heart. So it will always be very comfortable to go back and watch the diagram to understand what is the flow that is happening with the system. Another thing on Jaeger is the monitor tab that you can see here. This is an overview of your all services. So you can normally go and check different services, and from the services go down to the operation level and take a look at different time frames and understand if there is a problem. So as you can see here, this is like the problem we will try to monitor in a minute or two. The service performance monitoring tab shows you anomalies in the behavior. Here, for example, we see that our orders service suddenly has a spike of 8 seconds, which is not normal for our order processing. And the question is, how are we monitoring all this scenario? And then we'll go back to the time that the event happened. When the event happened, we might get an alert that was pre-configured into the system to notify us that something is going wrong with the payment service. We can monitor the payment service latency or the error rate on the payment service, and set a level that will announce that something goes wrong with that. Examining the alert, we can directly jump into a dashboard that will emphasize what's happening with our SLO. So here we can see the numbers that look pretty bad right now. We like our payment service latency to be really close to 99% and on. So we see that in the last minute something went wrong. We can see the latency graph that is going up. And this is a good time to explain that these metrics are not infrastructure monitoring metrics. It's not metrics that come from servers or from a Kubernetes infrastructure. These are metrics that represents the application health. And the application health metrics are extracted from the spans and traces that we originally sent to Logz.io. So we use these metrics to give like an aggregated view, and with that we can spot that something overall is not going right. We can see this blue line here that indicates that sometime before this occurrence, there was a deployment of a new version. You can see that deployed version 0.44 of payment service was deployed by Tomer, which is really suspicious because we see that it affects the payment service. So from here, we can go to a more overview look on the whole SOC shop, see different business metrics, and try to understand if there is an effect of that issue on additional parameters. And we see this is definitely affecting everything. We see that the orders latency is going up. We see that the order rate is dropping dramatically. So this is not just a temporary incident. This might be something that we really want to investigate deeper. And we can use our SLO dashboard to jump directly into slow traces. Here are our slow traces. You can see that the trace view shows us exactly in one glance that things are not happening exactly like we expect. So we can see errors pop up directly here on the trace by trace view. We can see the exact microservices where the errors occur. We can see how long it took, so we can focus on these slow traces. Some of them took 9 seconds. So to conclude a payment in 9 seconds is not something that we really want. And from here, we can just select one of the traces that look very similar in the behavior and deep dive into them to try and focus on the errors. So we see that there is an error already on the orders service. Each of these line here represent one span, as Dotan explained, is one execution operation, one part of the overall request. So we can either look at the slow ones that have long lines or specifically look at the errors directly. So when I open a span, I can get a lot of information that helps me pinpoint the problem directly without the normal procedure of going, to a huge amount of logs, starting searching and filtering, looking for different strings. Here I can focus on the error and then check the context, which might be relevant and might not be relevant, because if it's a global problem, maybe it's relevant to all the code, but I can look at the context that indicates where exactly is the span happening, which environment, which cluster, maybe region, and this can help me focus on the issue. And further than that, I can go to the logs that are really, really important and really like attached to the span. This is something that is happening in the instrumentation and allows me to add logs directly to the span to be able later on to use this troubleshooting process to focus on the exact information that is relevant. So here I see that there is a timeout issue, timeout problem, which is a good indicator of why it takes so long to process, but it doesn't give me enough information to understand the problem. So I try to go to the payment span, and when I open the log here, I can see additional information that the payment gateway is unavailable. This is like more focused data. And if I look carefully at the payment gateway, I see that the URL for the gateway is dev.sockshop.payments. Well, from my time as a developer, I can recall that forgetting to properly set the configuration for the production environment might be something that happens. And remembering that we had this deployment just before the event started, I can now assume pretty confidently that maybe the developer didn't configure the payment gateway right on this change, and instead of using the prod payment gateway, use the development one, which caused the whole sequence of actions here to fail. And this is where I'll ping the developer, ask to take a look. The span here indicates directly where it was happening. It's in the authorized payment operation under the payment microservice, and you can take it from here and hopefully fix the issue. And maybe after that, let's look for the general dashboard. I can see that things return to normal after the fix. The order rate is becoming okay again. The latency is not high. Everything looks smooth and flowing good to the system. And that was a description of the troubleshooting flow through tracing. I'd like to go back to the Jaeger, which is, you can see it here, as one part of Logz.io platform where the logs and metrics already also exist, and indicate a few important issues. One is the search. The search, like you saw, can focus you on different aspects that are important for your scenario. Either you know there is some performance problem that you want to troubleshoot and you might want to look for the specific operation. You might want only to look at errors and then add like the error indicator to search for it. Yeah, like that, no errors in the last hour. And as I showed also, you can look for specifically slow spans in the process, and you can put it here and also limit the number of results. Another thing that is very powerful in the Logz.io platform, and we'll take one trace, for example, is the ability to say, okay, I'm looking for some issue, but when I look at the specific span, I don't see the logs I want. I need to see more logs. And I can drill directly from the trace to the Logz.io logging solution. And with the trace ID, look for logs that include that trace ID to be able to investigate more of the data. Naturally, this goes both ways. If I start from the logs, I can have a field that is trace ID that links me to the trace directly. And if I start from the logs and want to check specific issues with the order of happening, I can look at the trace and conclude the data that is missing for me. With that, I'll go back to the presentation to talk about some more aspects of the Logz.io platform and distributed tracing. So you saw the service performance monitoring. Saying again, this is like part of the Jaeger open source project, but contributed and developed by Logz.io. We believe that it is essential to take the product from the trace by trace level into the aggregated view, where you can check the overall health of your services and specific operations. And how do you achieve this ability? How do you get these metrics going into the platform? We will talk about it in a second. I want to show another use case that can be observed through the traces themselves. You can see here a typical view of the trace timeline, like I showed you in the product. And what is easy to see here is that the spans that all involve access to some Redis, maybe in-memory database, all this access is happening in sequence. You can see that each orange line starts after the previous one. So this is an indicator of a potential bottleneck, potential slowness in the system that can be easily solved if you add some pooling into your Redis access. And when you allow several connections to take place at the same time, the view on Jaeger will change to indicate that all these brown lines now that are similar to these accesses on top are not happening in sequence, but are happening 3 at a time. And once one is completing, immediately another one can get into the work. And this way you can achieve a visibility that your performance was improved. So going back to the way data goes into Logz.io, either traces and the metrics that you see in service performance monitoring, it all starts, as Dotan explained, from your application. The first process that is not avoidable is doing an instrumentation. We recommend using OpenTelemetry as the tool, as the libraries to get your instrumentation running. It's pretty easy to start. You can start with auto instrumentation, which is supported for the major development languages. Once you attach an OpenTelemetry agent to your executable code, you will get the spans flowing out of your application, and then you'll use an OpenTelemetry collector to direct them to a backend. It can be your own backend or Logz.io in our case. What's important is that the same data that you use to instrument your traces and spans is used to get the metrics that are coming into the metric backend for service performance monitoring. So you see that we take the same spans and we divert them into two pipelines, one just sending the spans and traces so they can be viewed in Jaeger one by one, or the metrics that are extracted from each span. And these are the classical RED metrics, red metrics, a term that you will often hear. And those metrics are embedded already in the spans. R stands for request, which is used to measure the request rate. We have the number of requests flowing in, so we can count them and understand what's the rate. You have the E for errors. As you could see previously in the demonstration, the errors clearly indicated on the span, so we can count the number of errors, compare it to the overall number of spans, and calculate the error rate. It's a good indicator that something is going wrong. Like you saw on the troubleshooting scenario, error rate went dramatically up, which triggered maybe an alert. And the D stands for duration, which is naturally the most important metric that is provided by distributed tracing and the span creation. Each span has automatically its duration, and this is you can use for the overall calculation of latency of the application. So basically, you don't need to create very specific application metrics. You get it all automatically just by instrumenting for spans and traces and sending them through OpenTelemetry. Let's talk about best practices, because if you want to start tomorrow, you can do a set of things to get you going. So we talked about instrumentation. This is a process that involved developers, and as developer time is very expensive, we want to use it very efficiently. So the recommendation is always to instrument gradually. If you are like a person that wants to push distributed tracing into your organization, the best is not to go over all teams and like force them or ask them to instrument, but to choose some important business path, like for example, the one that we saw, payment, and just instrument maybe the initial services that are responsible for that. Once you start with a good and solid path that is instrumented, you can probably see low-hanging fruits of problems that will immediately pop up on Jaeger. So you can demonstrate within the organization how tracing can be used, and from that point on, you'll probably get more support and get more people involved in instrumenting the overall code. It's important to remember that it's not about how much we instrument. It's important to emphasize that the most important part is the quality of instrumentation. And it's better to get it straight in some places, make sure we're doing the right things, and then evolve to the overall organization. Once we get our instrumentation right, maybe it's automatic instrumentation, things come up that require more data into the context of each span and trace. And this comes when you find yourself troubleshooting and need some really business specific data. The automatic instrumentation adds some tags, some attributes into your spans, but you will find out that you might want to add user ID or some other custom attributes that will help you understand better when something goes wrong, what is the case. Also, the logs that you want to add directly into the spans are something you have to do manually. And again, you need to select the places that are important for that and not do everything all together. Another thing that I also showed in the demonstration, the ability to go from logs to traces and back can really happen if you add more structure to your logs. If you connect your logs to the concept of trace and maybe span by just adding to the same logs you already write, just add a trace ID and span ID. These attributes can be easily retrieved from the OpenTelemetry library that you are already using for instrumentation. Last thing is about the sampling that Dotan also mentioned. Why do we need sampling? Well, it's all about storage. Eventually, in order to be able to search efficiently through your traces, you need to index them. Now, indexing storage is quite expensive, so you don't want to index all the traces. Tons of traces are created for applications that have many microservices. So, and most of the time, you don't need all of them, because normally we want to use this data when something goes wrong, when we try to find out what's wrong with performance, where are the errors happening. when this case happens, we can focus only on the important traces. So we can apply different rules using configuration in OpenTelemetry or using tools that Logz.io provides. And we can, for example, decide that we want to collect traces that have errors. These are immediately indicators for a problem. We want to sample the slow traces that are also something that we can go through and understand if there are bottlenecks. And we can set the rules that will apply based on the importance of service. Overall, all these rules can be applied with what's written here as tail sampling. Tail sampling is the ability to collect all the traces together in one place in OpenTelemetry collector. And once we have it collected, we can make the decision based on the logic that we apply. This is different from a head sampling that is focused on very simplistic attributes like the trace ID to decide if there's a probability we want to keep, like for example, 10% of the traces. We look at the trace ID, do some hash coding, and decide if we want to take the trace or not, and act accordingly. Sampling, it's important to mention, is not like dropping logs from our collection. In sampling, we need either to take, based on one of the spans within the trace, we need to make the decision for the overall trace. We will not throw out single spans, but either take all the spans of the trace together into the indexing backend or throw them as a whole. This is a big difference as opposed to logs. Last thing is about sampling the metrics. One of the things that is important about the metrics that we collect for the health of the application for the service performance monitoring is to get the metrics from all our data. So how does it work when we say that it's a good practice maybe to sample out the non-important traces? Well, the way we do it is that we configure in the OpenTelemetry collector the collection of metrics as explained previously, and we can do it just before we throw the unimportant traces. So we get this way 100% of the metrics we need, and just after that, we'll get rid of the traces that are not important for us and keep the balance between a lot of metrics that indicate on our system health and some important traces that we later might want to investigate in order to reach the correct conclusion. And this way we will get the dashboards that are based on the metrics to represent correct numbers and can attach the alerts and all the troubleshooting steps that were described previously. With that, I'll conclude my presentation. Thank you for attending and being part of this webinar.
Fantastic. Thank you so much, Arya, for that great demonstration. We have a couple of questions and just a few minutes to get to them. The first one is, can distributed tracing work with serverless functions?
Yeah, so, okay, so we talked generally about the instrumentation. This is a good place like to show the screen also. What we have here is on our tracing product, we have a documentation page that has instructions on how to integrate from different languages, from different technologies. And one of them is also like Lambda functions, for example. This is the one. So you can get all the instrumentation working within your Lambda function. It's all our documentation. You have very simple steps and detailed explanation on how to go through it and properly implement in your code.
Great. And if I have a local Jaeger running and I want to switch to Logz.io, how complicated is that?
Well, the whole idea of OpenTelemetry is exactly this idea. OpenTelemetry is a framework that relieves you from doing instrumentation again and again when you want to switch implementations on the backend. So mainly once you instrument using OpenTelemetry, the only thing you need to do, for example, for transferring from your local Jaeger to Logz.io is to change some simple configuration on the OpenTelemetry collector. It's a piece called exporter. We have a Logz.io exporter where you can configure your credentials, your specific Logz.io token. And once you restart your OpenTelemetry collector, the same spans that were sent to your local Jaeger will flow into the backend of Logz.io. Real simple process.
Great. Here is another question. I think, Dotan, this is from your section. In the DAG, there was a question about B and E being concurrent, but the trace being sequential. So could you talk a little bit about clarifying that?
Yeah, so I used the visual to demonstrate what a trace would look like. The DAG, the acyclic graph, directed acyclic graph, was just a way to depict the flow of traces through the through the trace from span to span in terms of the graph, which is very similar to what you can see here. On a aggregated view on the system view. So system view is not a single trace, it's actually aggregation across all the service calls. But what I showed before is sort of similar to this, but a single trace. However, this view obviously does not show the concurrency between them. For that, we turn, maybe Faria can show the timeline view. This is the classic view that you saw. Most of the investigation that Aria demonstrated was done on top of this view, the Gantt chart. This very clearly depicts which calls are being done concurrently, which one are done sequentially, and that obviously makes it easy to detect if things, for example, that run sequentially could potentially be parallelized to reduce the overall latency of the system. I hope that clarifies the question.
Yeah, thank you very much for that. We have time for one more question, and then we need to wrap it up. We're coming up on the top of the hour. How do you add distributed tracing to your Kubernetes cluster?
Okay, so again, this is like a question of integration, but what we have for that, and we developed it lately, maybe I can show that as well. Okay. Okay, you can see that we, in addition to different technologies that you can follow step by step, you can use the Logz.io telemetry collector, which is kind of a new thing that we added. It's an agent that relieves you from implementing different technology for collecting data. It's not only for traces. The amazing thing about the agent is that it relieves you from separating your telemetry collection, so you can focus on just deploying it to one of the Kubernetes environments that you might have. And then you can decide which of the telemetry data you need to collect and change the toggle here respectively. And once you have it, we'll generate for you the proper backend accounts. And with that, you just generate a snippet which you deploy on your specific environment, either Mac, Windows, or Linux. And we take it from there. But just deploying this simple snippet, you can send all the telemetry you selected directly to Logz.io. It's kind of new. It's a no hassle agent. really recommend that you take a look. You can start a free trial from the Logz.io website and follow the instructions there.
Excellent. Thank you so much, Ariad. Thank you for Dotan for being our presenters today for our first customer-facing webinar. And thank you to everyone who attended and stuck around through to the end. Like I said, we are working on making this a monthly webinar program. So as soon as we shut down the broadcast, there will be a follow-up survey where you can provide your feedback, your ideas for future webinars. We really appreciate all of that information. Just a couple of quick questions that should take about 2 minutes to fill out. Thank you again to both of our presenters. And if we didn't get to your question, I'll make sure that one of us or someone from your account team reaches out to make sure that they get answered. So that is it from us today. Thank you, thank you. Everyone have a great rest of your day.
Thank you.
Thank you.